going from the word equation to a balanced equation. And it says carbon tetrahydride plus oxygen becomes water plus carbon dioxide. First thing that we need to do is we need to do what's called the skeleton formula. This is the unbalanced equation. So the first thing I'm going to write is I'm going to write the formula for carbon tetrahydride. What would carbon tetrahydride look like? First of all, is it covalent or ionic? It's covalent. Carbon, what's the symbol for carbon? Let's make this bigger. C. Hydride, what's that? That's hydrogen. What does tetra mean? Double check, is that formula by itself, does it satisfy the crisscross rule? Well, hydrogen has a charge of 4 negative. Carbon has a charge of 4 negatives. Each hydrogen has an atom to give. Yeah, this is a legal covalent compound. What am I going to write for a plus sign? Plus. What's the next element? Carbon tetrahydride plus what? Oxygen. What am I going to write? Nope. O2. Why am I going to write O2? The fancy phrase for this, we said that oxygen was diatomic. It does not appear on its own in nature. And in fact, I gave you a word. The word was these are the diatomic atoms. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. Now you can remember the word Hofbrinkel, or there's another way to get them as well, sort of from your periodic table. If you look at your periodic table, which I have, where here, Mr. Duke? Way up here. Aside from hydrogen, which is this one, what were the other ones? Oxygen, nitrogen, fluoride, fluorine, chlorine, bromine. They sort of form a number 7. See them? So hydrogen, and is that all of them? 1, 2, 3, 4, 5, 6, 7. Okay? So that's why it's going to be O2. Let's go back. Becomes. What am I going to write as a symbol for becomes or turns into or ends up as or produces? Not an equals. Arrow. Here's our chemical reaction symbol. Water. Hopefully you've memorized that one by now. Plus carbon dioxide. CO2. This is what's called a skeleton equation. I've written out the compounds, but I haven't yet tried to balance the number of atoms in each. And we said, until you get really good, the best way to do this is to start listing how many of each there are on each side. Right now, how many carbons are on the left? How many carbons are on the left? 1. Because that 4 is on the H, right? Not on the C. How many carbons are on the right? 1. Oh, we're balanced. Well, no, we got to check more. How many hydrogens are on the left? 4. How many hydrogens are on the right? How many oxygens are on the left grand total? 2. How many oxygens are on the right grand total? Count carefully. 3. Are we balanced? Nope. Which one, hydrogen or oxygen, am I going to want to start with? Well, according to the textbook, they suggest if you notice that one of your elements appears in more than one compound, leave it for later because balancing the other stuff might just take care of it. So let's try balancing hydrogen first. Okay? Justine, how many hydrogens are on the left-hand side right now? How many do I have on the right-hand side? How many would I like to have on the right-hand side? 4. How can I do that? Well, I guess if I put a 2 right there, that would make 4 of those. Yes? Oh, but how many oxygens do I now have on the right-hand side, grand total? Instead of 3, I have 2, 3, 4. So I'm going to go. Am I balanced? Not yet.
What is balanced?
Means the same number of atoms on the left, same number of atoms on the right. Okay? How many O's do I have on the left? How many oxygens on the left right now, Kenzie? Look what I've written. Right here. 2. How many oxygens do I have on the right-hand side now after I've put a 2 there? Okay. How can I make those equal?
Take away 2.
You're not allowed to subtract. You can only multiply coefficients on.
Then give oxygen to them.
Which side?
Left.
So if I put now I'm not going to say 2 more, I'm going to say times by 2, because I'm not adding. So you're saying if I put a 2 there, that would give me 4. Now, look back, stand back, zoom out. How many carbons on the left? 1. How many carbons on the right? 1. How many oxygens on the left? 4. How many oxygens on the right? 4. How many hydrogens on the left? 4. How many hydrogens on the right? 4. Are we balanced?
Yes.
We're done. So the actual equation, CH4 plus 2 O2s turns into 2 H2Os plus 1 CO2. Am I going to write the ones? No. But we are now balanced. Let's try another one. Iron plus bromide becomes iron 3 bromide. Okay. Step 1 is the skeleton equation. Iron plus. Now, I should have actually said bromine, not bromide. That's a typo. I'll fix it, but it's Br. What am I going to write for becomes? Arrow. Now, I got to be a bit careful. Because this is an ionic bond, I have to get the subscripts correct. So, over here in the margin, I'm going to write Fe and Br. Iron is multivalent. What charge of iron does this question want me to use? How do I know? Roman numeral 3. So I'm going to put a little 3 right there. What's the charge on bromine? What's the charge on bromine? So I'm just going to put a 1 right there. How do I figure out the subscripts? I'm going to crisscross. So the skeleton equation is going to be this. Fe Br 3. Brad, you saw I put that together? Little tougher than covalent, because when you read a covalent compound, they tell you how many of each there are by using the prefixes. In ionic, you got to do the crisscross, do some math. Okay, let's list our elements. How many irons do I have on the left right now, Kenzie? It's meant to be obvious. How many irons are there on the left right now? No. How many irons do I have on the left right now? 1. How many bromines do I have on the left right now, Kenzie? 1. On the right, how many irons do I have right now? 1. But how many bromines do I have on the right? Is that balanced? No. Brendan, what? You're right, I think. I think I can go like this. I can put a 3 right there. Is that what you're saying? and that would make 3 of those. Are we balanced? The toughest part there, I think, Brendan, wasn't actually balancing. It was turning this into that, into that. But can you see, we're actually basically now reviewing everything for the entire unit in one question. The naming, reading the periodic table, getting the charges, getting the valences. Let's do another one. This is so much nerdy fun. It's nerdically delicious.
So if it's a non-metal and a metal, you always have to crisscross them?
If it's an ionic one and they give you the name, you'll probably have to crisscross to get the subscripts correct. If it's covalent, because they'll tell you how many of each there are in the name, you can skip the crisscross step because you'll see the tetra or the penta or the mono and you'll know how many of each there were. Is that what you're asking?
So like even if it's not Roman numeral, you still crisscross it?
Yeah, because all the Roman numeral does is tell you the charge, not how many you needed to make it a legal compound. Yep.
So why can you just change that 1 into a 3?
I didn't change the 1 into a 3. I put a 3 in front right here, and what that's saying is, okay, if I put a 3 there, how many bromines are there on the left-hand side now? That's why then I changed the 1 to a 3. You add coefficients to the top skeleton equation, but then you make sure you adjust the numbers of each atom, and you're trying to get everything to balance. Let's try another one. This next one's tough. Okay. Tin 4 nitrite. Tin, is it multivalent? Nope. So over in the margin, what's the symbol for tin? It's a bizarre one. SN? What's the charge on tin? Well, that Roman numeral 4 tells me that. Nitrite. They didn't say nitride, they said nitrite. This is one of those polyatomic ones from the back of your periodic table. What the heck is nitrite? NO2? Like that? What's the charge on it? Just negative? Okay. What am I going to write for my skeleton equation then? I'm going to crisscross. It's going to end up being SN NO2 4. Yeah, I know, it's thrilling. Nice yawn. Ah! Nothing? Good look. Plus potassium phosphate. I can't just write the letter K and the phosphate. I have to balance the charges. So I'm going to go off in the margin. What's the charge on potassium? 1. Phosphate. They didn't say phosphide. It's not phosphorus. Phosphate's from the back. Miller, what the heck is phosphate? Sorry, I couldn't hear you. PO4. And what's the charge on phosphate? -3. So when I crisscross, how many potassiums am I going to need, really? You see it? No? Crisscross. Boom. Boom. How many potassiums will I need? Yes. 3 of those. How many PO4s will I need? Am I going to write the 1? No. Got it? What am I going to write for becomes, turns into? Arrow. Potassium nitrite. Okay, I'm going to walk over to the margin over on this side. Potassium, I know, is K, and we said it had a 1. What the heck is nitrite? That's also from the back, is it not? Because it didn't say nitride. Sorry, what is it? NO2? What's the charge on NO2? Is it? I need an authoritative. I don't need a 1. I need somebody to be able to... What is it from the back there? Just -1? Oh. When I crisscross, it's going to be a 1 and a 1? Am I going to write the 1s? Okay, so it's going to look like this. K, N, O, 2. Because there's only one NO2, the brackets are optional, Nicole. You can put brackets around there like I did right here, or not. Plus tin 4. Oh, thank goodness. SN. Tin 4, SN. All right. Now let's list how many of each element, how many of each atom there is. So let's say I have SNs, I have Ns, I have Os, I have Ks, I have Ps. And I already said O, so I don't need to write it twice. Over on the right-hand side, I'm going to have SNs, Ns, Os, Ks, and Ps. Oh, this is a tough one. How many SNs are there on the left-hand side right now?
4.
4 or 1? Which one?
1.
If there was 4, how would I show that? I would put that SN inside what? Inside brackets. So there's 1. How many Ns are there grand total on the left-hand side? 4. Because it's inside a bracket with a 4. Let's do the Ks because that's a little easier. How many Ks are there on the left-hand side? 3. How many Ps are there on the left-hand side? 1 or 4? Which one? 1, because that 4 is on the O. All right, now here's the tricky part. How many O's grand total are there on the left-hand side? Can you see it?
12.
12? Is 12 right? Let's see. We got 8 right here. 4 more there. How many are there grand total? Stop making noise, please. And do I really need to tell you that again? No. 12. All right, let's walk to the right-hand side. How many SNs are there grand total on the right-hand side? 1. Hey, we're balanced. Well, maybe not. How many Ns are there on the right-hand side? 1 or 2? That 2's only on the O, right? So just 1? How many Ks are there on the right-hand side? Yep.
Shouldn't it be SN3 on the other side because it's SN phosphate?
Oh, I didn't see the phosphate here. Good gosh, Mr. Dewick. Darian, that's my fault for not seeing the entire question. Sorry, that was dumb of me. It's not tin 4, it's tin 4 phosphate. Let's see if I can recover. Can you wait for a little bit, please? So, Brady, what was that? You saw it too? Or you were wondering? You're right, we have to fix this over here. So you know what? Let's erase the 1 or cross it out. We need to do SN tin phosphate. So tin phosphate, tin, it says, has a charge of 4. What the heck is phosphate? Not phosphide, phosphate. PO4? What's the charge on phosphate? On 3 negative? So when I crisscross, I'm going to have this. Tin, 3 of them, and then PO4, 4 of them. Sorry, people, that was terrible of me.
Does Darian get a candy?
Absolutely. So let's fix the right-hand side here. How many tins are there on the right? There's 3. How many N's? Well, the N's were right. Still 1. How many O's grand total? Can you see it? Where's 18 from? You're right. So 16, 17, 18. Nice. How many potassiums? How many Ks? 1. And how many phosphoruses? How many P's? 1? I think I disagree. I think because it's in the brackets, I think there's 4. Are we balanced? No. All right. Pick one. And I'm going to say, since oxygen appears in so many places, save oxygen for last. Maybe if we're lucky, it'll balance itself. Nitrogen, you want to start with? It's not balanced. What do you want to... I would probably start with tin. I don't know. Let's see. How many tins do I have? How many SNs do I have on the right-hand side? 3. How many on the left-hand side? 1. So one thing that I could do then, Kenzie, is this. I could put 3 there, but that's going to domino through a bunch of stuff. Curtis, that's going to give me 3 of those. But it's also going to give me 3 times as many nitrogens. So instead of 4, you know how many I'm going to have? 12. And it's also going to give me, instead of 8 oxygens, it's going to give me 24 oxygens. And 4 more still over here. It's going to give me how many oxygens now? Move this over a little bit. You guys with me? It's going to give me 8 times 3 is 24, and 4 more, 28. Sheesh. Okay, but I got the tins balanced. What do you want to try now? You know what? Let's keep working our way sideways. Let's try nitrogen. Since nitrogen, Josh, just changed and became a 12, let's see if that makes it easier on the right-hand side, because this equation does have to balance. So how many nitrogens do I have on the left-hand side, Josh, now? 12? How many do I need on the right-hand side then? Okay, how many do I have right now? So what could I do to this thing here? Put a 12 right there, right? That's going to give me 12 of those. Oh, how many potassiums will it give me? 12. How many oxygens do I have now? So I got to be a little careful here. This is tricky. I got to re-add them all. So I'm going to have 24 and 16. What is 24 and 16? 24 and 16. 40. Okay. Let's see. Tins are balanced. Nitrogens are balanced. Now let's try potassiums. Let's try the Ks. How many Ks do I have on the right-hand side? 12. How many Ks do I have on the left-hand side? Let me finish the lesson, then I'll let you go. How many Ks do I have on the left-hand side? How can I turn a K, a 3, into a 12? Times by 4? So let's put a 4 right here. That would times this by 4, making it 12. Oh, how many potassiums, how many phosphoruses, how many P's would that now give us? Also 4? Woohoo! How many oxygens do I have on the left-hand side grand total now? Well, now I've got 24 and 16. See it? 40. Holy smokes! Am I balanced? How many tins? 3 and 3. How many oxygens? 40 and 40. How many phosphoruses? 4 and 4. In fact, phosphorus took care of itself, and so did oxygen. How many nitrogens? 12 and 12. How many potassiums? 12 and 12. That's balanced. The actual equation is 3 SN NO2 4 in brackets, plus 4 K3PO4s gives me 12 KNO2s plus SNP, well, that thing. Last one. I think this one's a little easier. It's easier at least to get what we call the skeleton equation. Remember, the skeleton equation is not balanced, but you've got all the elements and atoms in the right places with the right subscripts. Carbon hexahydride. Hey, that's covalent, which means I can get the formula, Amy, right from the name. Carbon, symbol. How many? None. Can't be none. One.
I thought you meant
Carbon. Hydride, what's that?
6.
Well, first, what is hydride? Hydrogen. Hexa, how many? CH6. Does that work? Oh, let's see. Carbon has a charge of 4. Hydrogen, there's 6 of them already. Pardon me? I think I would say I'm going to put 6 here, and I'm going to put 4 of the 6 right there. Is that okay? Carbon, it doesn't have a charge. It doesn't say there's a charge of 4. You have to count back for it. Hayden, you okay? Okay, I'll get you later. Where was I? CH4H6. Sorry, C4H6. This is going to be C4 and 4 of those, I think. Let me double check. I think I'm doing this one wonky and overcomplicating it. Sorry, folks. Bear with me for 1 second. Folks, in front of the word carbon, there should be DI. It's dicarbon hexahydride. It's dicarbon hexahydride. Sorry. And if you're not lost already, I'm not doing anything to improve it. So dicarbon hexahydride. What does di mean, Miller? How many are there this time? 2. So it's going to be H2. How many hydrogens? What's hexa? Carbon. Good gosh, Duick. How many hydrogens? What's hexa? It's C2H6, and you don't reduce covalent ones. Plus.
Shouldn't the 2 be on hydride?
No. It's covalent. You don't crisscross. If in the covalent name they tell you how many of each there is. Okay? Plus oxygen. I'm not going to write O. What am I going to write instead? O2. Because it's diatomic. Becomes carbon dioxide. Hey, this one I got memorized. What's carbon dioxide? CO2 plus water. What's water? H2O. So there's our skeleton equation. Let's now try listing how many of each atom there are. So, on the left side, how many carbons? 2. How many hydrogens? 6. How many oxygens? 2. On the right side, how many carbons? 2 or 1?
1.
Because that 2 is on the O, right?
Oh.
1.
2.
How many hydrogens?
2.
2. How many oxygens grand total?
2. 3.
2 or 3? 3. Because there's O2 and there's one more. Are we balanced? All right. Let's start working on one of these. Which one do you want to start working on? Hydrogen, oxygen, or carbon? Carbon? Okay. How many carbons do I have on the left-hand side, Jake? 2. How many on the right-hand side? Okay, I can fix that. How? Put a 2 right there. That gives me 2 of those. Oh, but that changes the number of oxygens as well. How many oxygens do I have grand total now? 5. Let's try hydrogen. How many hydrogens do I have on the left-hand side, Justine?
6.
How many on the right?
2.
How can I turn, I think I can turn a 2 into a 6, yes?
Yes.
How?
Multiply
By?
3.
So let's put a 3 here, and that's going to make this a 6. Oh, that's going to change the number of oxygens on this side again. Now it looks like I have 4 and 3, 7. Are we balanced? Isn't it 8 oxygen? Where is there 8? No? Is it 7? Okay. Are we balanced? Well, how can we balance the oxygens? How many oxygens do I have on the left-hand side? How many do I have on the right-hand side? Justice, can I turn a 2 into a 7 very easily?
No.
Hey, what number do they have in common? 7 and 2. What number do they have in common? I heard someone say it quietly. 14. I think I can turn this into 14. So I can put, how can I turn 2 into 14? So let's put a 7 right here. That gives me 14. How can I get 14 on the right-hand side? Well, if I have 7, I think if I try doubling everything. So if I double everything, let's see if that works here. Is that what I want to do, Mr. Dewick? Let me double check. I think so. So let us try making this a 4. Making that a 6. What does that do? Let's see. How many C's do I have on the right-hand side now? 2 or 4? I got 4 now. Cross that out. How many H's do I have on the right-hand side now? 12? 6 or 12? I think 12, right? So cross that out. How many O's do I have on the right-hand side now? Let's see. I got 8 and 6. How many? 14. Am I in balance? No. Where am I unbalanced? Carbon. How many do I have on the left? How many do I have on the right? How can I change a 2 into a 4? You're saying if I put a 2 there, that's going to give me 4 of those. That's going to give me 12 of those. Miller, what? Holy smokes, they're balanced. If you're confused, I don't think I did the best job of explaining this, but some of you are getting the hang of this. I'm going to let you try practicing some. Wednesday, I'll do some more with you, but we are done the unit. You can expect a quiz on this either Wednesday, probably actually when I see you guys again on Monday, and I think your test is going to be either towards the... Pardon me?
You said Monday.
I said Monday?
Yeah.
Okay, Monday, next week. You can probably expect a test, not next week, but the week after, I think. Okay? What's your homework? Couple of things. First of all, you can try page 211, number 2, and then I have a worksheet with answers for you to work through. And we are done.